This is Geometry Unit 12, Lesson 3 on inscribed angles. We have talked about central angles, and those are angles whose vertex is at the center of the circle. Now we're going to talk about inscribed angles. An inscribed angle is an angle whose vertex is on the circle. So the vertex is on the circle, and whose sides, instead of being radii, are chords of the circle. So this is a chord, and this is a chord. Those are chords of the circle. Okay, so the angle that's created is right there. That's the angle. That's an inscribed angle. Now, how do we find the measure of an inscribed angle? It is equal to half the measure of the arc that it intercepts. Okay, so if I look at angle APB, what arc does APB intersect? Well, if we look at the endpoints of the angle, the chord right here, it comes to AB. So it's going to intercept arc AB. That's the arc it intercepts. So the measure of angle APB will equal half the measure of arc AB. The endpoints of the angle here and here, not the vertex, describe where the arc is. Okay, and vice versa. If we have the measure of arc AB, that means that the angle will be twice the measure of whatever the arc is. Okay? All right. So there's a couple of corollaries that go along with this. Remember, corollaries are like subtheorems that come from that. If two inscribed angles intercept the same arc, well, let's see. Let's draw that. If I have another inscribed angle that intersects that same arc, it cuts off the same arc. All right, so say this arc is 100 degrees. Okay, that means that this angle is 50 degrees. What's this angle going to be? Well, that also intercepts arc AB, so that's going to be 50 degrees. So if two inscribed angles intercept the same arc, they are congruent. All right, now, what if I had another angle on there? Let me do it a different color this time. Let's say I had another angle on there that doesn't intercept arc AB, but it has a measure of 50, or 100. Yeah, 50. All right, so let's say that's this angle right here. All right, and say that this angle was 50. Well, what does that make this arc up here? That's going to be 100 as well. All right, so this angle and this angle are congruent, so this arc and this arc are congruent, and vice versa. So congruent inscribed angles intercept congruent arcs, and vice versa. So if you have two angles that are congruent, the arcs they intercept will also be congruent. All right, so now let's do a little application. Find the measure of x in each diagram. We have x right here is an inscribed angle. Its vertex is on the circle. What do we know about the angle? It's half the measure of the arc it intercepts. So the measure of angle x is equal to half arc 80, this right here. So that means that it will equal 40. So this angle right here will be 40 degrees. All right, now, what do we know about the angle? It's 70 degrees. What do we know about the arc it intercepts? It will be twice. So x will equal twice 70-degree angle. So that means x is 140 degrees. So this is 140 out here. This is half of this. This is twice this one. All right, we have one more corollary. The measure of an angle formed by a tangent and a chord is equal to half the measure of the arc it intercepts. Okay, now let's remind ourselves what a tangent and a chord is. A tangent is a line that intersects the circle in only one point. So it intersects it right there at the point of tangency. All right, now this is a chord right here, a tangent and a chord. So if we're looking at this angle right here, it will be equal to half the measure of the arc it intercepts. So the measure of angle x will equal half of the arc that it intercepts, which would be half of 120, so that it equals 60. All right, so this angle right here is intercepting, you got to be careful what arc it's intercepting, from here to there only. So this angle right here intercepts here and here to cut off the arc. All right, now just for argument's sake, what would be the measure of this arc right here and the angle that goes with it? Well, if this is 60 degrees right here, what would be this one over here? Well, these make a line, so this would be 120. So, using that theorem, what should be the measure of the arc? Well, if this is an inscribed angle, technically, because this is a tangent and a chord, this means the arc will be twice that. So it'll be 240 degrees. Okay, so 240 plus 120 is 360 degrees. We've gone all the way around. Be very careful with the tangent and the chord because you have to see where the ends of the chord are when you do that. All right, let's do a little application now that we have our theorems. In circle O, AOB is a diameter, goes through the center of the circle. Measure of angle BDC is 30, so that's this angle right here, BDC. And the measure of arc AD to BD is 5 to 4. All right, so that means they're in the ratio of 5 to 4. There's some multiple of 5 and 4. So BD and AD would be 5x. AD is this arc right here, is 5x. And BD would be 4x. It's some multiple of that. All right, now we want to find the measure of angle CAB. CAB, which would be this angle right here. Okay, what arc does CAB intersect? Well, it intersects arc CB. So it will be equal to half the measure of arc BC, or CB. All right, so we need to know the measure of arc BC. Okay, so what do we know about any of the arcs? Well, we know these two right here add up to 180. And we know that this arc is also intercepted by this angle over here, so this is 30. So that's going to equal half of BC. To figure out BC, BC will be twice this angle because this is the inscribed angle. So that means that BC is going to be 60. Okay, so half of BC, that means it will equal 30 as well. So this angle is going to be 30. Okay, now going back to what I was talking about for the next thing, CBA. CBA would be this angle right here. If we want to find CBA, what arc does that intersect? Let me do it in a different color here. It would be arc CBA would intercept arc CA right there. Okay, so we don't know the measure of CA yet, but we might be able to figure it out. All right, so we need to figure out what the measures are. Okay, now remember that AB right here is a diameter. So if that's a diameter, that makes AB a semicircle. So AB, semicircle, is going to be 180 degrees. So if this whole thing is 180 degrees and this part's 60, what does that make AC? The measure of AC will be 180 minus 60, which is 120. So this is going to be 120. Okay, so the measure of angle CBA, CBA, will equal half the measure of arc AC. And we just found that AC was 120, so it's going to be half of 120, which is 60. So this angle right here will be 60. Okay? All right, now we need to find angle ACD, which is that angle right there. All right, ACD intercepts what arc? Let me see, I'll use green. All right, it intercepts arc AD. So that'll be half arc AD, whatever that happens to be. Okay, so again, this is a semicircle. So this side of the semicircle is also 180 degrees. So can't we figure out AD from that? Yeah. All right, so that means that 5x plus 4x will equal 180 degrees because this would be the whole semicircle across here. So 9x equals 180. So that means x is 20. So if x is 20, that makes AD 100. And it also makes BD over here is going to be 80. All right, so half of AD is going to be half of 100. So that's going to be 50. So this angle right here is 50 degrees. Now, all right, so all we have left is angle ACB and angle CEB. So let's look at ACB. ACB would be this angle right here. Okay, that's ACB. What arc does that angle intercept? Now be careful. It goes from A all the way over to B, because here's the angle right there. It's going to intercept that arc right there. So what is the measure of arc AB? Well, isn't that the semicircle? Yeah, so that'll be 180 degrees. So that's going to equal the measure of arc, half the measure of arc ACB. And ACB is going to be a half 180, so that means that's going to be 90 degrees. So an arc interscribed in a semicircle is a right angle. That's going to be 90 degrees. Okay, the last one is angle CEB, CEB, CEB. So it's this angle that's not on the circle. Okay, so remember we just found this was 90. All right, so if this whole angle is 90 degrees, this part's 50, what does that make this part? It makes it 40. Well, CEB is right here. What's the measure of the angles in the triangles? 180. Well, we have 40 and 60 is 100, so that means CEB is 80 degrees. Okay, so that is inscribed angles. The measure of an inscribed angle is equal to half the measure of the arc it intercepts, and the arc it intercepts is equal to twice the measure of the angle.